Your AllSky camera needs a brain, and that's the Raspberry Pi. In this video, we'll pick the right Pi for the job and flash its operating system from scratch with the official Pi imager. This part is all about the hardware, so you don't need to know anything from the earlier videos. Just a Pi, a microSD card, and a card reader. By the end, it'll boot up and be ready for the camera software. Grab your Pi and let's set it up. Now, if you don't already have a Raspberry Pi purchased, you can look at Amazon or whatever shopping site you use. Just do a quick search for Raspberry Pi 5 4 gig, and we only want the board. We don't want a case or anything like that because the case will not be installed inside the enclosure. There's just not enough space for it. Now, you have two options when you're looking at the Raspberry Pis. You have a Raspberry Pi 4, and this is the 4 gig model, and the Raspberry Pi 5 with the 4 gig model. And I wouldn't recommend going less than 4 gig, especially if you plan on using all of the features in the AllSky software. It just requires a little bit more resources to do the time lapses, do the keygrams, the housekeeping type things. You want to give it enough room to move around. And if you go with a 2 gig model, you're going to start constraining the resources on it while it's trying to do multiple processes simultaneously. Now, with that said, the Raspberry Pi 4, the Model B here that we have here, 4 gig, it's about $120. Now, the Raspberry Pi 5, 4 gigabyte, see our options, and let's see all buying options. What do we have here? Okay, so for $8 more, you're getting a much more capable processor and version of the Raspberry Pi. So I would highly recommend looking at the Pi 5 4 gig for $128. You may be able to find some other Raspberry Pi 4s, maybe much cheaper, but make sure you look at the memory that's on it. If it's a 2 gig model, you're probably going to starve your system for resources. So definitely no lower than 4 gig. You don't need to go with a 16 gig model. Benefits not going to be there for what the price is going to be. So just try to stay in the 4 gig range and you'll do well with that. Now with the system, it's the board only. It does not include an SD card. You'll probably want to look at, depending on how much data you're trying to capture, you may want to look at an NVMe drive with storage on it. NVMe drives are they're more write robust intensive, whereas an SD card, it does have a life expectancy after however many years it's been out working. So you definitely want to look at those two options. If you just want to start out basic, definitely just get you a 64 gig SD card and pop it in and you'll be fine for a while. But if you're looking at this being out there for years, and if you want to keep quite a history of your images and time lapses and things like that, then you'll want a much more robust NVMe drive that can mount. Basically, they have little hats that sit on here and it kind of just extends off the system. One other thing that you will want to get is when you get the board only, you need to look at a fan, because this board does not come with a fan as far as I know. I don't see any option. I did not see a fan included, but if you just get a Raspberry Pi 5 fan, I think it's about $10. Let's see here. They actually do have a manufacturer model that they will offer. This one right here, exactly. This is the official active cooler for Raspberry Pi 5. There's holes already on the board where these little punch through connectors will connect to the system with. This little cable, there's a pin out on the board that you'll plug this into that provides power to the fan, and it basically just turns the fan on and off as it needs to cool the processor down. And these enclosures do get warm, so you don't want to pop a Pi in there and have it start heating up, because it will throttle itself and it could even shut down if the heat is too high. All right, so with that stated, and if you have not chose your board, if you have not ordered it yet, those are the two that you'll want to look at. So now let's jump over and see how we can install the software. Okay, so with this, we will choose software, and we need the Raspberry Pi imager. So that's what we have here. Download for Windows. I'm running on a Windows box right now. They do have Mac OS and Linux distros that you can download for those operating systems. So we'll just go ahead and choose download for Windows, and we'll drop this into, let's see, look at the software folder here. Yeah, let's drop into our software. Okay, so here's our imager. It's already downloaded. Now we'll click on this. Now, if you're prompted, if you don't run Elevated or as an administrator on your machine, you'll be prompted for your password, which it's doing on mine right now. And then we will see OK. And basically what you want to do at this point, you'll have your SD card already inside a card reader attached to your computer. So when the Raspberry Pi Imager Setup Wizard starts, it's going to be looking, the next steps will be looking for where are we going to write this image to. Obviously, we don't want to write it to our hard drive, and it would probably fail on that. I'd never actually tried that, but you need to make sure you have an SD card already discovered by your system and available for the process to write to. So we'll choose next and accept the agreement. And we don't need an additional desktop shortcut. So let it finish the install. It's going to prompt you, do you want to install this additional software? Since we're not going to be using this Pi as a gadget or anything like that where we're attaching it to our computer, we're going to say don't install. We do not need that particular driver installed. Okay, now we will launch the Raspberry Pi Imager. Now when it comes up, you need to already have decided which device that you're going to install on. So if you picked a Raspberry Pi 4, you'll choose the Raspberry Pi 4. If you choose a Pi 5, then that's the option you'll select there. So we'll choose that. Next. Now which OS do you want? Indy AllSky does support the latest Trixie version, so you want to choose that top option, 64-bit Trixie. And in storage, right now it's detecting the SD card that I have in my card reader. It's only a 32 gig SD card, but that's fine for what we're doing on this. Is 32 gig is sufficient. If this is something that you're going to have in your system you plan on having it for years, you'll probably want maybe 128 or 256 gig just to be able to accommodate the amount of images that will be written. Choose that drive. We're confirming that's what we want to install it. Okay, so what is the name of your host system? This is an old build that's detected, so we're just going to call this AllSky, and then we can hit next, and then what's your location? Choose whatever capital city that you live near. All right, next. Now this is where you want to put in the login information, because you're customizing the actual build information that when we take this SD card out of our writer, we're going to put it into our Raspberry Pi 5, and when it boots, it's going to read this information off the card, and it's going to set up the operating system with these parameters that we're specifying now. So it's important that whatever information you provide here, that you remember what it is, because when you go to log into it later, it's going to expect you to know this. So I'm just going to type in AllSky as the username, and we're going to do an incredibly insecure password. We're just going to type in password. Obviously, you want to have good security hygiene and use random passwords. Don't reuse the same ones, but if it's on the inside of your network, yeah, you can get by with using a weaker password. But AllSky, and our password is the word password. Confirm that you've actually typed in what you think you did. Those two are correct. All right, and we'll hit next. This is where you're going to set up the Wi-Fi. Go ahead and enter whatever the network name is. So the SSID, on mine it's Farm at Woods Edge, and then a password. You want to make sure that you enter the correct password, because like I said, these are parameters that are written to the SD card. So when you pop this into your Raspberry Pi, it's going to read all this information as part of the setup. If you get your Wi-Fi password wrong, your Raspberry Pi is not going to be able to connect to your Wi-Fi network. There's other ways to get around that. You could attach your Raspberry Pi directly to your switch and let it get a DHCP address like that, but less convenient. So you will go ahead and put in your information, and then you'll hit next. Okay, so we have our information in. We have our SSID and our password. We'll click next. Okay, you do want to enable SSH. SSH is basically a way to remotely connect to the Raspberry Pi during our setup. So make sure this is toggled. And then you do want to use a password authentication. We won't get into the public key authentication. That's kind of outside the scope of this video, but for now, we're just going to use the user password and authentication on that. That's the AllSky username and the password, the word password that we set up earlier. Next, we're not going to enable the Raspberry Pi Connect. We don't need that right now. You can always do this later. Okay, and now it's ready to start the writing of the SD card. We'll hit write. You're about to do this, and if there's anything on that card, it's going to wipe it off and rewrite this new data on there. So make sure this isn't, your SD card doesn't have family photos and stuff that's very important to you. Preferably just make sure it's a new card. You won't have to worry about that. Okay, it's finished writing. Now it's going to verify that the write was successful. Okay, the Raspberry Pi has finished writing. You can see it says write complete. You would look through here, make sure there's no error messages. For the most part, it's a pretty straightforward process. There's rarely any issues that I have whenever I'm writing using the writing software to do this. So we'll hit finish, and then we will remove the SD card from the writer, and we will take it into the other room, and we will pop it into the Raspberry Pi and make sure it boots up. Okay, we're ready to take a look at our Raspberry Pi 5 board. Now, if you've never seen or worked with any of the Pi computers, you'll notice the first thing is they're very small. Small but capable. One thing you definitely want to make sure is that you hold it by the edges. You do not want to grab it on the face or the back because you have a printed circuit board on the back and you don't want to short it out. So definitely while you're holding it, make sure that you're gripping it by the corners. You do not want to static discharge and ruin your device. So if taking a look at the ports that we have here, the very first port is a USB-C power port. You have two HDMI ports. The first HDMI port closest to the USB-C is your monitor output. So, and if you had a monitor like I was just showing on the background, that's something that you could hook up to that port for troubleshooting purposes, things like that. Of course, you'd need an adapter that connected to it, which will be a micro HDMI to whatever HDMI input you have on your other side. Now these little ribbon connectors, this is where your Pi Cam HQ with a ribbon connector would slide into. Basically, the ribbon would fit down into the slot and you would push the little tab down to lock it into place to keep the ribbon from disconnecting. And this little white port, this is your power port for the onboard fan. Row of pins is your I/O ports. This allows you to control different sensors like humidity, temperature. You could also control on-off switches for different fans, things like that. And then on the end, we have an RJ45, your standard network cable connection. And then we have several USB ports. You have USB 3.0 and the 2.0. On the back side, we have our SD card reader. Now on the back of the SD card, you have gold contacts. Those need to face down so that they're actually facing towards the board. Make sure it's snug whenever you push it all the way in. Ideally, you will use a power adapter that has a USB-C connection because that's going to be a more modern power supply and it should provide sufficient output to power your Raspberry Pi 5. I think the Pi 5 has a 5 amp output requirement. I'm going to go ahead and plug this into my power supply off screen here, and then we'll hook up our USB-C cables and power this thing up. Now, when we plug this thing up, one thing we're going to be looking for is this little LED. This will flash red when it first boots, and then it will go green. And then after a few seconds, you should start seeing the green light flash. As long as you see that, you know the device is booting up correctly. If you get a red-green flash alternating, then you got a problem and troubleshoot further. But for the most part, as long as you wrote the image, you didn't get any error messages, you should not have any problems with this boot process. And we'll turn this light off so that we can actually see this light on here just a little bit better. All right, so there we go. Yeah. Okay, so now you see the light flashing. This is typical of our back in the day when we had computers that actually had hard drive activity indicators where it's flashing, you know it's working. So this is telling you that it's reading the SD card, it's going through its boot process and getting ready to be in a state where you can connect to it remotely. So we'll go ahead and put the board down and we'll go back to our workstation and we'll log into it remotely. Okay, we're back at our workstation now and we're ready to check for the Raspberry Pi network connectivity. What you can do is, if you'll recall what you entered as your host name whenever you were writing the image for the Raspberry Pi, on this one that we're setting up now, we called it AllSky. So you can type in at your command prompt, type in ping and the host name AllSky. And you should get a response. As long as you get a return, then you know the device is on the network. I'll give you a scenario. If something wasn't correct, we'll just type in the host name incorrectly. We'll say AllSky1. Now, if we hit AllSky1 when we're pinging it, we'll get it could not find the AllSky host. It couldn't find anything to ping. That's an error message saying it could not find it on the network. So if you get a situation like that, you'll need to troubleshoot your AllSky or your Raspberry Pi and just verify that it did in fact it did connect to your Wi-Fi network and it did actually get an IP address, or troubleshoot and try to find out what else may have happened on that. It may be something as simple as just rebooting the device, or you may actually need to go in and verify that the device did connect to the wireless network. And we can do a quick troubleshooting trip on that right now. Okay, now we're at the troubleshooting phase of this chapter. If you did not have any problems getting your Raspberry Pi set up, then just skip this part and move on to the AllSky configuration. But if you did have issues, then you're in the right spot because we'll go through some troubleshooting steps. So the first thing to do is log into your router, your local router, your Wi-Fi router, and see if you have a DHCP lease tab or a section for DHCP leases. Sometimes in there you may be able to browse the different host names and see if something showed up in there. You'll remember in our scenario we use the host name of AllSky. Maybe you use that same name and maybe it is showing up on the list. If it is, great, grab the IP address. You'll be able to communicate with the device more than likely, but you still need to troubleshoot why your own computer is not able to resolve the host name. But if nothing is showing up in there and it's making sense on how to troubleshoot it from that side, then you need to come to the physical device, and that's where we're at now. We're back at the workbench, and the tools you need to use to troubleshoot are a keyboard and mouse. So this is a all-in-one keyboard mouse. I've got a Bluetooth transmitter connected to the USB port, and then we have this monitor that's sitting right below this, and it's just an HDMI connection on the monitor. You have an HDMI output on the Raspberry Pi. You just have to make sure you have the right connectors, because so the Raspberry Pi HDMI port, it's a micro HDMI. So we will go ahead and connect the micro HDMI port, and then make sure you have the connector facing the correct direction. Push that in, and then you see the monitor just lit up behind it. So a couple things we'll look at here, and I'll turn off this light so there's no glare on it. All right, so first thing we want to look at is, do we in fact have Wi-Fi connectivity? So on this scenario, if you did have Wi-Fi connectivity, awesome, you're already one step ahead. We just need to figure out why you're not resolving the host name. This, when you hover your mouse over it, you see it has the network name. We have our farm Woods Edge, and then we have the IP address, so 192.168.1.102. Hopefully that's showing up on the screen. But in the event that did not have a network connected to it, if this had two lines, and I'll show you what that looks like. We'll turn off the wireless LAN. If it looks something like this, then that means your Wi-Fi did not get connected at all. It may even be grayed out. It may not just say have the red line through it. It may just be grayed out. So with that, we will just click on that, turn on wireless LAN, or if the wireless LAN is in fact on but you're not connected, then you would see a list of wireless networks. Go ahead and click on your wireless network name, type in your password, and it should connect. Now, if you're at a command prompt, you can bring up a terminal window, and you can type, if you're at a command prompt, you didn't have a GUI running, you could just type in ifconfig, hit enter. And on this, we're going to scroll up to look and see what IP address was assigned. We have on here ETH0, Ethernet 0. This is the physical LAN port. This is the one that a cable would actually plug into. We're not using that, so we'll skip on down to the next one. And now we have our WLAN 0. This is a wireless LAN, so 192.168.1.102. That was what we saw in the graphical interface version of it, so we know that part's fine. Again, if you're only working from a terminal and you don't have a way to get into the GUI, the way to get into that is you will type in sudo raspi-config, hit enter. And this basically just gives you a little menu to work through. So all your network settings are going to be inside the system options. The one we're selected on now, option 1. We'll hit enter, and again, the wireless LAN is the very first option. So we'll hit enter on that. Now at this point, you would type in your SSID. That's your wireless name. Mine would be Farm at Woods Edge. I would type that in, and I would hit OK, and then it would go to what's your password for that, and you would type in your wireless password, and then hit OK again, and it would try to connect. And if you typed in everything correctly, it should connect right away. If you didn't, you'll have to do some additional troubleshooting steps that are kind of outside the scope of what I can really cover in this video without making this a 2 or 3 hour video. Go ahead and cancel out of this, but those are some of the troubleshooting things that you'll want to do in the event that you did not get the ability to ping the host name. But if you do have the IP address, you're not dead in the water. At the very least, you can still continue, but you'll need to troubleshoot why you're not able to get to the host name, because that can come up to problems later, especially if you're not using DHCP reservations. If you're using DHCP, that means your IP address could change periodically. And if you don't have a host name where the router is automatically associating that host name with the IP address, a month from now, you may try to connect to your AllSky by IP address, and if it's changed, you're not going to be able to connect to it. That's why the host names are always the most reliable route to go. And on top of that, a DHCP reservation in addition to the host name. This means it will use a DHCP server to assign the IP address, but it will always automatically give you that IP address every single time. It's almost like a static IP address, but not having to keep a spreadsheet to keep track of all your static IPs.
And that wraps up part 3.
Your Raspberry Pi is chosen, flashed, and booted, ready to go. Next, we bring it to life. Part 4 is already up where we install the AllSky software. That's a software that actually captures the sky. Have your Pi powered on and your camera handy and click straight into Part 4, linked right here. The whole series is live if you want to keep rolling. If your Pi gave you any trouble, tell me in the comments. Thanks for watching, and I'll see you on the next one.